Hi children, let us study a little bit. Here's class 8, subject science physics, chapter 1, the matter. Now the chapter matter you have studied in chemistry and in physics both. Right now when you come to study the chapter matter, first thing that you should know what matter is, or what is matter, or what is the definition of matter. Let us start like this. Anything, any object on the surface of the earth that has mass, that occupies space and can be perceived by the senses. Now if you do not understand what is perceivance, that is nothing but realization. That means when you touch something, then you can know what matter is this. I am telling you one thing, that the air cannot be seen. We cannot see the air, but we can feel the presence of it. That is perceivance. That means we can perceive air by the touch. Alright, so anything that has mass, occupies space and can be perceived by the senses, realized by the senses, is known as the matter. This is the matter. Why this is the matter? Because this is occupying the space. It has little bit of mass, and if you close your eyes also, you touch, you know that this is a substance. So anything that has mass, occupies space and can be perceived by the senses is matter. That is the definition. Now, kinetic molecular theory of matter. The matter is made up of the molecules, and the molecules are further made up of the atoms. So the matter is made up of the molecules and the atoms. So we say matter made up of the molecules. And the molecules in the matter are in motion, always motion, they are in motion. So when there is something in motion and their characteristics coming into a theory known as kinetic theory of the matter. So it is kinetic molecular theory of the matter. So molecules are in motion, number one, that is the point. So what is happening though? The matter exists in 3 states, rather 4 states: solid, liquid, gas and plasma. Usually we study under solid, liquid and gas, and molecules having movement in all solids, liquids and gases. They are in continuous motion. The motion is vibratory or translatory. Now what happens, the solid, suppose this is a solid, there the molecules are there. You can say, where is the movement? We cannot see the movement. So that is why this thing should be noted at, that vibratory. The movement in the solid is very less, but they are vibratory, always there. Don't think it is not there. So it is vibratory movement. On the other hand, the other motions are translatory, like the liquids and the gases. The translatory movement means particles are moving, gaining energy, increasing in motion, colliding with each other. Whatever it is, they remain their total sum of energy intact, same. Alright. In fluids, the movement is zigzag and random. Fluids means liquids and gases. Why? Because they flow, that is why they are known as the fluids. They flow from the higher level to the lower level, higher concentration to the lower concentration. That is why they are fluids. In fluids, the movement is random and zigzag. Zigzag means the movement is like this. Like this. This is zigzag movement, and random means always going on. This was first been observed by a scientist known as Robert Brown. And so this is known as Brownian movement. What it is called as? Brownian movement. They are known as Brownian movement. Well, Brownian movement. Now I told you, when the molecules are in having energy, so they are in motion. So what happens? They move. frequently and total energy remains same after collision of the particles. When they move, sometimes they collide in liquids and gases, I told you, because in solids it is only vibratory motion, little bit of motion is there, not like that moving here and there and zigzag and random. So they get collide and they get the collision each other, and then sometimes they reduce the energy, sometimes increase the energy, but whatever it is, total sum of energy remains same. Well, the kinetic molecular theory says the motion is directly proportional to the absolute temperature of the gaseous system. Suppose say we have introduced some temperature in the liquid and in gas. What will happen? The molecules will gain more energy and their movement will become frequent and faster. Faster movement that will be there for the gases and for liquids. Okay, that's happening there. And then states of matter, we have solid, liquid, gas and plasma. Let us see what solids are. Solids are the matters. This is a state where the shape is retained. Shape, size, volume is retained. What is happening here? The molecules are very tightly arranged. Suppose say the solids are having very solid, no molecular gap in between them, no intermolecular spaces are very less, intermolecular force of attraction is also very less. No. The intermolecular force of attraction is greater, and whatever the force in between the molecules is known as the cohesive force. What is known as cohesive force? That is there. So intermolecular force of attraction is more. They have only vibratory motion, no translatory motion is there. They retain their volume, shape, size, etc. So they are a little bit of rigid. They have less compressibility. They cannot be compressed more. If you compress them more, they will break. So that is why compressibility is very less. Well, we have now the liquid. In liquid, the molecules are loosely arranged. The molecules are loosely arranged, and so that they can cause the zigzag and random motion. Zigzag and random motion they can do. They don't have their proper shape. When they are poured in a particular container, they take the shape of the container. That is, the liquid has the shape only when they are placed in the container. So if you keep them in a bottle, they will be the shape of a bottle. In a small bowl, there will be shape of that ball, or a bucket, they will take the shape of the bucket. That's all. So that is happening because the molecules are far too loosely arranged. They are loosely arranged, not very far too loosely arranged. They are loosely arranged and they can take the shape of the container. And their molecular force of attraction is less and cohesive forces also less. So that is why they can take the shape. They have definite volume but no definite shape, and size is definitely not, because they take the shape of the container and they have a particular volume there. So that is liquid. We have the gas. The gases, the molecules are far too loosely arranged. The gases, the molecules are far too loosely arranged. Here, there. Far too loosely arranged. So they are zigzag, random, all motions are there. That is there. Their force of molecular attraction is very less. Compressibility is very high. They can be compressed in a very small container. Example I give you. That LPG cylinder, have you seen the LPG cylinder? The cooking gas, that means the gas by which we do the cooking, that is there. What is there, 14.5 kg comes in the domestic gas cylinder. 14.5 kg gas is a huge amount of gas. But that is kept only in that container because they are more compressible, and as they are compressible, so they can be compressed and put into the cylinder in a high pressure. Then how do they move? When you release the pressure, so they move from the higher pressure to the lower pressure zone, what I told you earlier, because they are the fluids, they flow from the higher pressure zone to the lower pressure zone, and that is why they are known as the fluid. So that is the do. So in gases the molecules are far too loosely arranged. Gases have no definite shape and volume always. Okay, so that is how it is there. So there is another state is there which is discussed nowadays is the plasma. What happens in plasma? When electricity or heat is passed through the gases, what will happen? The molecules and all those, they break and split, and they are very hot and illuminated. That is known as the plasma. In plasma, you say in the stars, in the evening you say aurora borealis. Aurora borealis, if you look at the aurora borealis, you see the ray-like things are coming out from them. That is the plasma, the concept has come from there. Okay, so solid, liquid and gases and these are the three things. So how we will compare them? The solids, definite shape, definite volume, size, less compressibility, least vibrative motion in the molecules, and the most molecular force of attraction, that means the cohesive force is more. In liquid, the molecules are far too loosely arranged, take the shape of any container they are poured in. They have definite volume, no definite shape. Alright, they are having in the molecules zigzag and random motion, which is known as the Brownian movement, and then they also exert pressure to all parts. Their cohesive force is less, and the molecular attraction force also is less than the solids. When we come to the gases, in gases the particles, that means the molecules are far too loosely arranged. They are moving faster and they are more compressible. Their intermolecular force of attraction is very less. Their intermolecular force of attraction is very less, and their cohesive force is also very, very less. So they move from the higher concentration region, that means higher pressure region, to the lower pressure region. So is in liquid. So they are known as the fluid because they flow from the higher to the lower level, or flow from the higher pressure to the lower pressure, and that is how we use the cooking gas for our different uses. Their force of molecular attraction is very less, the cohesive force is very less, and they are very much compressible. So huge amount of gas can be kept in a very small container. Well, to the plasma, what I say, that is the plasma, it's very, very fine particles. So molecular force of attraction and all those obviously will be less, and they can move from one place to the other. Okay, some properties by which the changes are. Boiling. Boiling is the property by which the liquid changes to gas. So boiling is a state when a certain liquid attains a particular temperature at which it starts changing from the solid state to the vapor state. And as it starts boiling, as long as it boils completely, the temperature remains same. So it is known as the boiling point, and the process is known as the boiling, and it is the cause is the change of temperature, that is there. And the boiling point, I explained it, of water starts boiling at 100 degrees Celsius. So its boiling point is 100 degrees Celsius. Well, as soon as you put a pan of water on an oven, it does not boil. It starts slowly and gradually vaporizing. So what is vaporization? It is the liquid starts changing the state from liquid to the vapor. That means the gaseous state. I explain you, the vapor and the gas is not the same. Gases are gases in normal temperature like oxygen, carbon dioxide, hydrogen, nitrogen, etc. in the nature. But the vapor is not that. Vapor is the converted form of liquid. That means the increased temperature on a liquid causes the state to change from the liquid to the gas, and this is known as the vapor. So that is the difference between the vapor and the gas. All right. Now let us see that process is known as vaporization. Now melting. Melting is related to the solid. You see, I will give you one example. Take a cube of ice and keep it in front of you on the table. You see, after some times that will start slowly and gradually melting. That point from where it starts melting and ends into melting is known as the melting point of an object. So melting point of an object is that temperature. And then we have fusion. Fusion is another property whereby heat the molecules fuse together. So that is fusion. Then evaporation. What is evaporation? You have seen in your daily life, looking towards the surrounding, the jhels, the lakes, the rivers, the seas, the oceans, anything else, wherever there is water, drains, and all the sewage, dirty to the most fine waters, whatever it is there, water bodies, they evaporate. What is evaporation? Slow and gradual changes of the liquid to the vapor or to the moisture and goes high up into the air and stays the moisture, which is known as humidity. Anyway, so that is the vaporization, evaporation. So evaporation is a surface phenomenon. It happens from the surface, and as wide as the surface is, the evaporation is more. So an evaporation, or suppose say you have taken two liquids, one in a small cup, same amount in a plate. The surface of the plate is more and surface of the cup is less. So you see, in course of time, the water of the plate will be evaporated fast than that of the cup. Why? Because the surface is more. Number two, second factor of evaporation is that if you increase the temperature, evaporation will be faster. You increase the wind, you just put on one cup of water and a plate of water and charge fan. What will happen? There will be windy, and as the wind will be more, the evaporation will be faster. So wind causes faster evaporation. That is the thing. Well, energy increases, evaporation increases, and it is a very, very important phenomenon by means of which many chemical aspects can be explained. Now we have condensation. My dear children, during the winter night, sometimes you have seen your daddy or uncle or somebody else or your grandfather or else you, sometimes you take the glass full of water because you do not know when you are in the bed at night when the water will be required. Most of the times we do not have the water, that water remains on the table. During the winter night, in the morning when you get up, you see the droplets of water are there just outside the glass. Suppose say this is a glass and water was kept in it on the table. On the table the water was kept on it by covering with a plate or something else. In the morning you will see the droplets of water will be outside the glass. The outside the glass will be the droplets of water. Why this is happening? Do you think that there is a leakage in the wall of the glass vessel or there is a leakage the wall of the steel vessel? No, it's not. Then what? It is nothing but due to the lowering of the temperature, because in winter days temperature is very, very less and sometimes it drops at night. So the atmospheric moisture will condense by cooling and will be deposited on the body of the vessel where the water was kept. So this is called the condensation. Now we have the sublimation. Some objects like iodine, camphor, etc., they have a characteristic to change right from the solid to gas and again from solid to gas again. So first thing, when the object or some special object like camphor, iodine, all this, they are known as sublime substances. What are they known as? Sublime substances. And the process by which they change from the solid to the gas and from gas to the solid. Solid to the gas is known as sublimation. Gas to the solid is known as deposition. So this is happening there. So you can test it by taking a funnel. In a funnel, suppose say this is a container, this is a petri dish or something else where some camphor is kept, and one funnel is introduced here, and then cotton plug, heat it by Bunsen burner. By Bunsen burner you heat it. What will happen, you know? As soon as heat is there, the iodine will be instantly changing into gas and will be deposited over there. That is called sublimation. What is known as sublimation. On the other hand, if they are cooled, that gas will change into the solid again, and that solid will be changed into the gas again. This is known as deposition. This is known as deposition. So sublimation, what is the opposite process? Is known as deposition. So sublimation and deposition are the two processes. Okay, we come to the next point, which is known as freezing. Freezing is the process by which something comes below 0 degree and keeps in the same thing as the water. Suppose taking water, if you just keep them and just allow them to go below 0 degree, they freeze, and this is known as freezing. And what happens, you know, as soon as the water starts freezing, they take a particular temperature and stay there for the freezing to be done. This is known as the freezing point. So that is what the freezing, and the freezing point is there. Well, children, so we were explaining about the freezing. So we have come to know about the matter. Matter is anything that has mass, occupies space, and can be perceived by the senses, that means realized by the senses. Second thing is that kinetic molecular theory of matter says that the molecules are always in motion. Well, the solid, liquid and gas, the molecules are having movement in all the molecules in solid, liquid and gases, all states. And the continuous motion, one motion is vibratory, that is applicable for the solids, because solids, the random movement is not there. It's movement, only the vibratory things are there. While in liquid and gases, translatory movement is there, and frequent zigzag movement is there, which is known as Brownian movement, observed by the scientist Brown. Well, the total energy in liquid zigzag is there. The total energy remains same after the collision of the particles. As the particles move in gas and liquid, they collide. They collide, but whatever it is, reduces the motion, increases the motion, whatever, total some energy remains same. Well, this movement is directly proportional to the absolute temperature of the gaseous system. That means if you increase the temperature, the movement will be faster. Decrease the temperature, movement will be slower. That is happening there. Well, now states of matter, solid, liquid, gas, and another state is there, which is known as plasma. I tell you, the solid, the molecules are very, very tightly arranged. No intermolecular spaces, almost no intermolecular spaces. Intermolecular force of attraction is the most, and the forces between the molecules is known as the cohesive force. In liquid, the molecules are loosely arranged. They take the shape of the container, while the solids have their own shape, own volume, own size. Liquids, only volume, no shape, because the shape they take for the container. And their force of molecular attraction is less than solids, and they have more gaps in the molecular space, and also they have less cohesive force. In gases, the particles are far too loosely arranged. Liquids have Brownian movement, so does gases have also Brownian movement. Random frequent movement in the molecules are there. They collide, and whatever it is, increase or decrease the energy, final energy remains same. Well, after that, the plasma, here you see the plasma, if the gaseous object has been heated too quickly, the particles will blast and just comes around with some illumination, like aurora borealis in the nature we can see. So this is plasma. Now we have some events to follow the boiling, the phenomenon from which the liquid starts changing into the gaseous boiling. The temperature at which it starts boiling and completes the boiling is known as the boiling point. Vaporization, that is the liquid start becoming the vapor, the vaporization. Then the melting is the state from the when the solid starts changing into the liquid, and then the temperature at which it does completely start from melting to the complete melting is not a melting point. Now the fusion is also that the complete melting and adding with the other one is known as the fission. And the evaporation is a surface phenomena in river, chills, lakes, drains, whatever it is, the water bodies or any liquid. If you just keep open, it will evaporate into the air from the surface. So evaporation is a surface phenomenon. As big as the surface is, that much more evaporation is there. We have the more temperature, so more evaporation is there. Windy, more evaporation is there. So that is how the evaporation follows. And the condensation, I explained to you at night, if you keep some water, you will see due to the fall of the temperature in the winter, the outside glass of the glass vessel, you will have the droplets of water. That is called the condensation. And there is a phenomenon called sublimation, where some substances called sublime substances like camphor, iodine, and these substances changes directly from the solid to the gas. This is known as sublimation. And when they changes from the solid to the gas, it says about sublimation. But when they are changing directly to the solid from the gas, they are known as the deposition. And after that, freezing is a phenomenon where the liquids start changing into the solids. And the point at the temperature at which they changes completely is known as the freezing point. So this is all about the changes there. Then we come to the changes of state. You see there is a diagram, the solid, increase of temperature, they are changing, solid is changing from to form melting in. Solids change by melting to liquid. And from the liquid, by evaporation, by changing on gases, they go on to form gases. And from the gases, the condensation brings the liquid in, and then solidification makes the solid again. And from the solid, by sublimation changes to gas, and by deposition, they come back to the solidification. So this is all about the chapter physics, and we have some question answers to discuss. Kinetic molecular theory of matter. Question E1. The theory which visualizes that all substances, whether solids, liquids or gases, are made of molecules in motion is called the kinetic theory of matter. So this is E1. Let us see other things what are there. So what is process of deposition? The process of deposition helps the gaseous state to change from the solid state directly. When the water vapor is in the air, comes to contact in cold window glasses, the kinetic energy in water vapor is lost, and this changes the gas into solid directly without passing through the liquid state. So this is the answer of question number 8. And question number 7. What is the place of question number 7 of E? Let us see question number 7 of E. Just a minute. Yes, question number 7 of E is explain the change of matter from liquid state to gaseous state. It is the phase of transition. Liquid phase changes to gas phase at the boiling point. Boiling starts when the pressure of the vapor on liquid is equivalent to the external pressure on liquid. Temperature remains constant. As boiling point, it takes place in the entire mass of the liquid, from the entire mass of the liquid. Well, next question. Explain the change of matter from liquid state to solid state. Okay, the process by which a liquid changes into the solid is called freezing or solidification. The temperature at which the liquid freezes under 1 atmospheric pressure is the normal freezing point. Here, energy flows from the water to air. Some molecules in water move slowly, which is enough for attraction in water between the molecules when all the molecules are orderly arranged in the process of freezing. So, I think these are the questions to be discussed, and you have understood the chapter, and thanks for this. Thank you and have a nice day. Well, one more thing to discuss, that is all the question answers of the chapter you will get it in school website, which is known as www.bsnes.in. Till today, thank you and have a good day.